Greetings to everyone. Myself, Dr. M. Harivanan, working as an associate professor in Department of Civil Engineering in Mari Lakshman Reddy Institute of Technology and Management. It is an autonomous institution which is located at Dundukal, Hyderabad. I am handling the subject of surveying and geomatics to the second year civil engineering students. Today we are going to discuss about the determination of areas for regular and irregular boundaries and calculation of volume of earthwork to the cutting and filling quantities, that is embankment quantities for level section. Also, we have to calculate the capacity of reservoir, how the way we have to calculate that we are going to discuss by today's class. Calculation of areas and volumes. So the main objective of the surveying is to calculate the area and volume. Okay. So generally the lands, whatever the land we have in our field, that consist of irregular shaped boundaries or polygons. Okay. So if we are having some regular shape like triangle, square, rectangular, okay, then other polygons, or we can have readily available formula. Okay. But in case of irregular boundaries, okay, now then we have to go for some other options or some other methods or some other rules to calculate the area of those boundaries or those land. Okay, that we are going to discuss. Now we already discussed that our surveying work mainly involves with areas and volumes. So when we are going to calculate the value, okay, that volume we can calculate when we go for an earthwork. So earthwork, where and all we can have the earthwork. So the excavation of channels, digging of trenches for lot of purpose. That is for laying of underground pipelines, formation of bunds, earthen embankment, digging, farm ponds, then land leveling and smoothing. So these are all the some examples of work which involves or which have the calculation of volume of work. And in most of the cases, when we go for the volume of earthwork calculation, okay, now first we should calculate the cross-sectional details or cross-sectional area, okay, and we have to get some interval, whatever the measurements we are taking out for the cross-sectional details, it should be taken with some common interval along the length direction, along the cross-sectional direction, okay, now, to the entire length of our either pipeline or channel or embankment or bund, whatever it may be, along the cross section at some interval, we have to measure the cross sectional details. After finding that, we can go for volume calculation with the help of some formulas like prismoidal rule or trapezoidal rule. Now, calculation of area. So there are several methods are used to calculate the area of a irregular boundary traverse. In that, some of the common method which are adopted to calculate the area of those irregular polygon, such as first we have to classify based on the offsets and coordinates. Okay. So based on the offsets, there are four methods like mid-ordinate rule, average ordinate rule, trapezoidal rule, and the Simpson's one-third rule. Then based on coordinate, there are three methodology are available. One is area from coordinates, second one is by latitude and meridian distance method, that is MD method, and third one is double meridian distance method, that is DMD method. So these are all the methods are available to calculate the area of the irregular boundary field. First we should go the topic under the calculation of area using offsets. So first one, mid-ordinate rule. So this rule states that if the sum of all the ordinates taken at midpoints of each division is multiplied by the length of baseline having their ordinates. Okay. Here this is ordinate O1, O2, O3. These are all the ordinates which has been taken at the point. Okay, now? But we have to calculate only at the mid ordinate, which means we have to take here the average of the height. Okay, so that I'm going to take, this is h1, this is h2, that is the midsection of two ordinates, h2, h3, h4, like that. It can continue till how many measurements we have taken. Okay. Now the mid-ordinate rule formula becomes, that is average ordinate, that is h1, h2, h3, h4. Okay. Sum of the average ordinate is multiplied with the base length, that is nothing but d is the base length, that is the distance between the two consecutive ordinates. Then second rule, that is average ordinate rule. This rule states that the average of all the ordinates taken at each of the division of equal length is multiplied by the base length divided by number of ordinates. So the formula becomes average ordinate multiplied with length of base. It becomes sum of the ordinate wherever we have taken for the irregular boundary from the baseline, that we have to O1 plus O2 plus O3 plus O4 plus O5 plus O6. Those ordinate is multiplied with number of equal length, that is the baseline has been divided by number of equal length. Okay, now that length we have to take it. So here in this diagram, 1, 2, 3, 4 and 5. So the baseline has been divided into 5 pieces of equal distance. Okay. So here n equal to 5 and d equal to the common distance. So the formula is O1 plus O2 plus O3 plus On into n into d, the whole divided by n plus 1. So this is the formula we are going to use to find the area using average ordinate rule. And third one, trapezoidal rule. So here the areas enclosed between the baseline and the irregular boundary are considered as trapezoids, and the formula is used for the trapezoidal rule is area equal to distance, that is common distance d into first ordinate plus last ordinate divided by 2 plus remaining ordinates. Okay, so this is the formula, that is d into O1 plus On divided by 2 plus remaining ordinates O2 plus O3 plus etc. up to On. Okay, then fourth one is Simpson's rule. Here the area enclosed between the baseline and the irregular boundary line are to be considered as parabola. So the formula becomes area equal to the common distance d divided by 3 into first ordinate plus last ordinate plus 4 into even ordinate plus 2 into remaining odd ordinates. Okay, here we have one constraint, that the Simpson rule is applicable only when the number of divisions or the number of ordinates are in odd. That means the number of divisions are in even and the number of ordinates are in odd. Okay, so this is the restrictions given from the Simpson's rules. So if we have an even ordinate, at the time for the last two ordinates we have to calculate the area with the help of remaining three rules, that is either mid-ordinate rule or average ordinate rule or by uh, trapezoidal rule. So now we will discuss about the comparison between trapezoidal and Simpson's rules. Okay, now this is with respect to some limitations, and in this calculation of area using offsets. Okay, now we have that is the first two methods, the mid ordinate and the average ordinate rules. Those are some, they won't give some accuracy in result. Okay, now so if we whatever the work we are having, and for the preliminary works we can use those two methods, those two rules. If we need exact answer, okay, now at the time we have to give or we have to use Simpson's rule alone. Okay, now even though the trapezoidal rule is having the results of with result less accuracy. So now we can move on to the comparison between trapezoidal rule to Simpson's rules. Trapezoidal rule. The first one is the boundary between the ordinates is considered to be straight. Okay, or trapezoids. Okay. Under Simpson's rules, the boundary between the ordinates is considered to be an arc of parabola. Okay, now then next second point in the trapezoidal rule, that is there is no limitations. It can be applied for any number of ordinates. There is no, we never bother about either odd ordinate or even ordinate in the case of trapezoidal rule. But the Simpson's rules is applicable only for odd ordinates. Okay, if we have even ordinates, then we have to go for some other methods for the last two ordinates to find the area. Then remaining evening, sorry. So for the remaining odd ordinates, we have to go with the Simpson's rules. So that is the limitations we are having in the Simpson's rule. And third one, it gives an approximate result, that is trapezoidal rule. But if we need accuracy in result, then definitely we should go with the Simpson's rules. So these are all the comparison between the trapezoidal and the Simpson's rules. So now we should go for the problem related to the areas using offsets. So let us discuss the problem. Problem 1. The following offsets were taken from a chain line to an irregular boundary line at an interval of 10 meter. So that here the D is 10 meter. Okay, the offsets are 0, 2.50, 3.5, 5, 4.6, 3.2 and 0 meter corresponding to the baseline to irregular boundary. Compute the area between the chain line and the irregular boundary line and the end of the offsets by the four rules: mid-ordinate rule, average ordinate rule and trapezoidal rule and Simpson's rules. So whatever the detail they have given, that we have drawn in the form of diagram. Okay now. So first, so this is our baseline, which means where we can get this kind of work. Okay now, or this kind of irregular boundaries. For example, this is our site. Okay. So now I have to make an baseline. Baseline is, we already said that, the line which connects the maximum length of the field. Okay now, and it should be in a straight line. Okay, this is our baseline. Okay, so from the baseline we have to get the, or we have to find the distance of the boundary. So here it is 0. Okay, and we have to choose some common interval that is called D. Okay, so along the length of the baseline we have to use some common interval D. So from here, with the help of cross off, okay, we have to make a perpendicular line. We have to make a perpendicular line. So that line denotes, or by measuring that line we can get the offset distance. So here it is D1, here D. Okay, from here to here, this is, sorry. So for the common distance we have to take the reading. So this is called offsets. Okay, O1, okay, from here also. Okay, O1, O2, O3, O4, like that. This is an ordinates corresponding to the distance D. Okay, O5, O6 and O7. Okay, so whatever the field we are having, we can have some issues like this. Okay, even though if we have land like this, okay now, then we can form a rectangular or square or whatever it may be inside. Okay now, after that these fields are, we can call it as irregular boundaries. Okay, so that also we have to calculate. Okay, when we have to calculate the area, so these things we are dealing in the surveying when we go for land area calculation. Okay, so these are all the offsets. Okay, here, and this is the area. So by adding all these, okay, 1, 2, 3, 4 and 5, we can get entire area of the field. Okay, now we should move on to the problem. Okay, now, so the first offset is 0, the second offset is 2.5, the third offset is 3.5, fourth offset is 5 and the fifth offset is 4.60, then sixth offset is 3.20, then the seventh offset is 0. Okay, now the count has been in the form of odd, okay, odd number, so we can go for the problem. Okay, so now the formula by using mid ordinate rule. So area equal to h1 plus h2 plus hn into d. This is the formula. Okay, so now I need the average height here or mid ordinate here. Okay, so by taking the average between the reading consecutive readings, okay, now I can get the mid ordinate. Okay, so that the h1 becomes, okay, 0 plus 2.5 divided by 2 whole divided by 2. Okay, now for h2 2.5 plus 3.5 whole divided by 2. For h3 3.5 plus 5 divided by 2. For h4 5 plus 4.6 divided by 2. For h5 4.6 plus 3.2 divided by 2. For h6 3.2 plus 0 divided by 2. Then we can get the heights of individual mid ordinates. Okay, now the area is, okay, here the distance they have mentioned that 10-meter interval. Okay, so 10 is d, so 10 into this mid ordinates 1.25 plus 3 plus 4.25 plus 4.8 plus 3.9 plus 1.60. By adding up we are getting the answers of 188 meter square. Okay, now next we should move on to the average ordinate rule. The formula is O1 plus O2 plus etc plus On into n into d, the whole divided by n plus 1. Here n is 1, 2, 3, 4, 5 and 6. Okay, so n equal to 6, the number of divisions equal to 6, and the distance between the ordinates base distance which is equal to 10-meter, that is equal to d. Okay, then the number of ordinates I already said 7 numbers, 1, 2, 3, 4, 5, 6, 7. Okay, so 7 I'm going to use. Okay, n plus 1 here, so n equal to 6. So by substituting these values here we are going to take direct values of ordinates. So our ordinates are 0 plus 2.5 plus 3.5 plus 5 plus 4.6 plus 3.2 plus 0. The whole into multiplied with 10, that is distance d, multiplied with n, that is equal to 6. The whole divided by n plus 1, 6 plus 1, so 7. So that I am getting the answers of 161.14 meter square if I am going to calculate the area using average ordinate rule. Next, by trapezoidal rule. So we all know the formula of distance d into first ordinate plus last ordinate divided by 2 plus the remaining ordinates. So the distance is 10, our first and last ordinates are 0, okay, divided by 2, it becomes 0, then plus remaining ordinates, so 2.5 plus 3.5 plus 5 plus 4.6 plus 3.2. So by multiplying these terms I am getting the answers of 188 meter square. Next, by using Simpson's rules, here the area is equal to d by 3 into the whole bracket, okay, first ordinate plus last ordinate plus 4 into even ordinates plus 2 into remaining odd ordinates. Okay, so this formula is applicable only if the ordinates are in odd. Okay, now so we are getting and we have our ordinates are in odd ordinates, that is 7. Okay, now so now we can go to the calculation, that is 10 divided by 3 plus, okay, first ordinate plus last ordinate. Okay, now that is 0 plus 4 into even ordinates, that is O1 O2. So 2.5 plus O4 5 plus O6 3.2. Okay, close the bracket, plus 2 into remaining odd ordinates. So remaining here O3 and O5 are available. Okay, now so plus 2 into 3.5 plus 4.6. Okay, so by calculating this I am getting the answer of 196.66 meter square. So this is the variation we can get when comparing with the trapezoidal rule, mid ordinate rule and the average ordinate rule, the value of. Okay, so next to problem, the following offsets were taken at 15-meter intervals. So here d equal to 15 meter from a survey line to an irregular boundary line. The offsets were 3.5, 4.3, 6.75, 5.25, 7.5, 8.80, 7.90, 6.40, 4.40, 3.25. Okay. Calculate the area enclosed between the survey line to the irregular boundary line using trapezoidal rule and the Simpson's rules. Here, the offsets ordinates O1, O2, O3, O4, O5, O6, O7, O8, O9 and O10. Okay. So here the ordinate are in even number. Okay. So then we go for a calculation of using Simpson's rules. Okay, now at that time we have to calculate two times the area. Okay, now which means, so this is our first part. It consists of the odd ordinate. Okay, so that is applicable for Simpson's rules. Okay, now and if we go for the remaining, that is last one, the area under the O9 to O10 ordinate. Okay, now that should be calculated with the help of trapezoidal rule. Okay, this one we are going to follow. Okay, when we go for the Simpson's rules. Okay, now but in the case of trapezoidal rule, so as it is we can apply. Okay, so now the formula is under trapezoidal rule. So the area is d into first ordinate plus last ordinate divided by 2 plus the remaining ordinates. Okay, so our distance is 15 meter and the first ordinate is 3.5 and the last ordinate is 3.25. Okay, now divided by 2 plus remaining ordinate, that is 4.3 plus 6.75 plus 5.25 plus 7.5 plus 8.8 plus 7.9 plus 6.4 plus 4.4. Okay, now the area using trapezoidal rule is 820.125 meter square. Okay, now we should move on to Simpson's rules. Okay, so I already said we have to consider two parts. One is from O1 to O9. Okay, now and the second part is O9 and O10. So under O1 to O9, whatever the area we can have. Okay, now that is first part that we can calculate with the help of Simpson's rules. Okay, first, so A1 equal to area 1 equal to d by 3 into O1 plus, that is first ordinate plus last ordinate. First ordinate is 3.5. Here the last ordinate is 4.4. Okay, here and 4 into odd ordinate. Okay now, sorry, 4 into even ordinate. 4.3 plus O4, that is 5.25 plus O6, that is 8.8 plus O8, that is 6.4. Okay, so these are all the 4 into even ordinates plus 2 into remaining odd ordinates. Okay, so O3, that is 6.75 plus O5 7.50 plus O7 7.90. Okay, by doing the calculation we are getting the answer of 8, sorry, 756, that is 756 meters square. This is with respect to our part 1. Then next to part 2. Okay, now that is for last two ordinates. Okay, that is by using trapezoidal rule we can calculate. That is d into first ordinate plus last ordinate plus remaining odd divided by 2 plus remaining ordinates. Here O9 is the first ordinate and O10 is the last ordinate for this part 2. Okay now. So 15 into 4.4 plus 3.25 divided by 2. So we can get the answer of 57.38. So by adding these two, okay, A1 plus A2, we can get the total area of the field. That is 813.38 meters squared is the area of the given field. So next, the third problem. The following offsets are taken from a survey line to a irregular, that is curved boundary line. Calculate the area by the trapezoidal rule and the Simpson's rules. Okay now. So that this is our given data. Here the ordinates are O1, O2, O3, O4 and O5. So up to this the interval is 5 meter, 5 meter, 5 meter, 5 meter. So this is D1 equal to 5 meter. Okay now. Up to this one part. Okay. Then second, here the distance is 10 meter, 10 meter. So here D2 equal to 10 meter. Okay. So here the offset O1 equal to 6.10, O2 equal to 4.70 and O3 equal to 5.80. Okay. This is up to this the part 2. Okay. Next, third one. Again, here the distance is 20 meter, 20 meter interval. Okay, so that the D3 equal to 23 meters. Okay, now the offset for this 20 meter, O1 equal to 5.80, O2 equal to 3.90 and O3 equal to 2.20. Okay, so if I am comparing with part 1, part 2 and the last is part 3. Okay, now all are under odd ordinate. Okay, now the given irregular boundary, okay, now has been divided into 3 parts. So with, by means of their base distance, okay, d1, d2 and d3. So by using that we have to calculate a1, a2 and a3. By adding these three area I can get my total area of the field. Okay, now we will discuss and go to the problem now. Okay, whatever I said they have given in the statement. Okay now, the interval between the offsets are not regular throughout the length, so the section is divided into 3 compartments. That is del 1 area of the first sections where the distance d1 equal to 5 meter, and the compartment 2 del 2 is area of the second section where the distance is 10 meter, and del 3 the area of third section where the distance d3 is equal to 20 meter. Okay, first area 1. Okay, so by trapezoidal rule the formula is d into first ordinate plus last ordinate divided by 2 plus the remaining ordinates. Okay, so the first ordinate for the portion 1 2.5 plus 6.10, okay, divided by 2 plus the remaining ordinates 3.8 plus 4.6 plus 5.2. Okay, so it's giving the area of 89.5. Next, the distance of 10 into first ordinate, that is 6.10 plus 5.80, the last ordinate divided by 2 plus the remaining ordinate 4.70. So this gives the answer of 106.5 meter square. Then third portion, okay, that is here. So the first distance d equal to 20 meter into first ordinate, that is 5.80 plus the last ordinate 2.20 divided by 2 multiplied with plus remaining ordinates, that is 3.90 is O2. So that is our the third portion. It gives the area of 158. Okay, by adding all these three, okay, I can get the entire area. So the entire area of the given field is 354 meter square by using the trapezoidal rule. Next we will move on to the Simpson's rules. Okay, here the formula has been changed for Simpson rule as d by 3 into first ordinate plus last ordinate plus 4 into even ordinates plus 2 into remaining odd ordinates. Okay, so that the first segment the distance d is 5 meter. Okay, so I'm getting the area of 89.66, and for the second portion my d is 10 meter, so that I'm getting the answer of 102.33 meters square. Okay, and the third portion the distance is 20 meter, and I am getting the answer of area is 157.33 meters square. So by adding all these three, okay, I am getting the answer of 349.32 meters square. This is the area I have got by using Simpson's rules. Okay, next topic is calculation of volumes. So I already we have discussed that whenever we are dealing with earthwork quantity like embankment or bund or trenches or pipelines, okay, whatever the work which have earthwork, okay. So in order to calculate the quantity of earthwork, either filling or cutting, okay, now that time we are need to calculate the volume of work, okay. So that volume has been calculated with the help of three methods. One is from cross sections, from spot level, and from contour. Okay, now so these three are the resource of readings. Okay, to calculate the volume. Okay, so first two methods are used to calculate the earthwork, and the third one, that is from the contours, we can calculate the capacity of the reservoir. Okay, now we should move on to the cross sections. Okay, now so this is the method which widely used all over the world. Okay, now and the total volume of the work is divided into a series of solids by the planes of cross sections. That is, I already said, if it is for cutting work. Okay, so this is my profile. Okay, that is this is my cross section details. Okay, here this is my breadth and this is my slope. Okay, n in 1. So this is my slope. this side and this side. Okay, now so that the top width becomes b plus 2 times of, okay, this distance. Okay, so if you are going to take this as w1, so 2 into w1. Okay, so by using the cross sections, and we have to take the cross sections at different places along the length. Okay, now in the length of the field. Okay, so here one place, and if I'm going to consider this is my path. Okay, so with some common interval along the center line. Okay, now some distance d or real whatever it may be, we have to take cross sectional details like, okay, by compiling that we can calculate the quantity of volume. So here the cross section can be classified into two different varieties such as level sections. Okay, now level sections means the edges of the two ends, okay, are at same level, okay. Then two level sections, so one side of the embankment and another side of the embankment or bund, whatever it may be, that is at different level. Okay, now there will be some height variation, okay, from the top to bottom. So here we can get another slope, okay, now along with the side slope. Then third one, side hill two level section. Here, if we are going for the hilly roads, okay, now that time we can get this kind of work. Okay, now which means, so this is our hill profile. This is our normal hill profile. Okay, so if I'm going to do the construction work here, okay, now then I have to cut the bundle like this. Okay, so here if I'm going to make the road, so up to this portion I have to cut the earth. Okay, now and whatever the earth I have taken or dig from here, that has been dumped into this place, so that filling has been taken place here. Okay, so this is the quantity, and here the levels are different here as well as here and here, so that this is one part, okay, and this is another part, so that's why it is called as two level section. Okay, at the hill. Then three level section here. Okay, now so here one level, here another level, and here another level, along with the side slope we can have this. Okay, and four level section, here also same, here one level, and here another level, and here another level, and here another level, along with the side slopes. So these are all the common things which we are having in the cross section details. Okay, now with respect to our syllabus we are having level section. Okay, so let us move on to the level section. So measurement on level section. Okay, here I already said this is our base width, that is B, and this is our side slopes n to 1 or n in 1, and the heights are equal wherever we have taken. Okay, now that is cross section of the height, okay, at different places. So by taking this throughout the length, sorry, throughout the cross section, the height is same. Okay, now the area becomes b plus nh into h. Okay, b plus nh, here this is nh into h. nh into h. Okay, so that here we are going to take or consider the area as a single length. Okay, now and multiplied with their breadth, we are going to get an area. So this is the formula we are going to use it. So here n equal to side slope, and h equal to the average height all in the cross section. Okay, b equal to base width of the embankment or bund, whatever it may be. Okay, now we should move on to the formula. Okay, now normally trapezoidal or prismoidal rule are going to use to find out the volume of the work. So this is the formula using trapezoidal rule. So V equal to H into first area, that is A1 plus AN, first area and the last area, okay, divided by 2. Instead of divided by 2, we are going to take it as zero point 0.5 plus remaining areas. Okay, that's why the formula is V equal to H into zero point 0.5 into A1 plus AN plus A2 plus A3 plus A4 up to AN minus 1. Okay, next prismoidal rule. So the volume is V equal to H by 3 into A1 plus AN plus 4 into A2 plus A4 plus AN minus 1 plus 2 into A3 plus A5 plus AN minus 2. So first area plus last area plus 4 into even ordinate areas plus 2 into odd ordinate areas, remaining odd ordinate areas. Here also as like our Simpson's rules, we have the constraint that the ordinate or the area ordinate should be in odd number. Okay, now we can move on to the problem. Here they have the given the problem as an embankment of width 10 meter and side slopes of 1 is 1.5 is to 1. Okay, so here n equal to 1.5 or 1.5 is required to be made on a ground which is level in a direction transverse to the center line. The central heights at every 40-meter interval has been taken as follows. Okay, so here this is our d we can take, which means the distance. Okay, now here in the formula also instead of h we can use d, that is comfort for us. Now the ordinates. Okay, so here they have said that the embankment. Okay, so this is our embankment. Okay, so width of the embankment b is 10 meter, and the side slopes 1.5 is to 1, so that is n. Okay, now the height. Okay, now at every 40 meter they have taken. For the first place, the height is 0.9 meter. That is at 0 meter, the height is 0.9. Okay, now next along the center line, the reading has been taken. So the second place, the height is 1.25. Okay, now then at the third place, it is 2.15. And fourth place it is 2.50, fifth one is 1.85, at sixth place it is 1.35, and seventh place it is 0.85 likewise. Okay, now so that the total ordinate is 7. Okay, now which is odd ordinate. Okay, now the distance between the first, the consecutive ordinates are is 40 meter. Okay, so if I have to calculate the volume, okay, first I have to calculate the area first at each and every places. Okay, so that the formula is B plus NH into H. Okay, so wherever I'm having the location now, at that place I'm going to calculate at each and every ordinates wherever I have find the central height. So here my B is 10 meter plus side slope n equal to 1.5 and 0.9 is my H1. Okay, so the area is 10.22 and H2. With respect to H2, the area is 14.84. With respect to H3, the area is 28.43. With respect to H4, it is 2.5 meters. The area is 34.38. With respect to H5, the area is 23.63. With respect to H6, the area is 16.23. With respect to H7, the area is 9.58 by using the formula of B plus NH into H. Okay. Now we have to go for calculation of volume using trapezoidal rule. So this is the formula. Okay. Here I am going to use D. Correct. So D equal to 40 meter into 0.5. First area into last area. So first area is 10.22 plus the last A7 is 9.58 plus the remaining, okay, remaining areas, this one, so that I am getting the area of 5096.4 meter square. Next, by using Prismadal rule, so H D by 3 into A1 plus AN plus 4 into even plus 2 into remaining odd areas. Okay, so that the distance is 40 by 3, so that the first 10.22 plus the last area 9.58. Okay, now then the even units plus 4 into 14.84 plus 34.38 plus 16.23. Okay, plus 2 into remaining odd ordinates. So plus 2 into 28.43 plus 23.63. So that by calculating that, we are getting the answer of 5142.9 meter square. So this is our volume of earthwork, that is for forming the embankment. So this much quantity we require. So here it is MQ. So this much of quantity we are going to dump for making of embankment. Next, so the second problem is related to contour. Okay, now, so the areas enclosed by the contours in the lake are as follows. Calculate the volume of water between the contours 270 meter and 290 meter by trapezoidal formula and prismatic formula. So the calculation of volume, okay, now using trapezoidal formula is as same like as this, and for prismatic rule as like it is same. Okay, now it won't change. Now I will explain how to calculate. Okay, now, so here this is our lake. Okay, now, so we can take this one as 270 meter RL. Okay, now, so each 5 meter they have taken 270, 275, 280, 285, 290. Okay, now, so the heights increase 270, 275, 280, 285. and 290. Okay, so corresponding to this, so here I can have the area with respect to 270 meter line, that is 2050 meter square. So this area, okay, they have recorded like this. Next, with respect to 275 meter, here 275. So whatever the area under this means, this one has come as a, that is at that point, okay, it can come as a 8400 meter square likewise. So now I have to calculate the volume. Okay, let us move on to the problem. So volume V equal to, so directly they have given the area. Okay, so only by substituting the formula directly we can get the answer. So H into A1 plus AN divided by 2 plus remaining ordinates in the trapezoidal formula. Okay, by substituting the values we can get the answer directly. Here the H is nothing but 5 meter interval. Okay, 5 meter interval, we are going to take it as a H or D. Okay, next, by using the Prismoidal formula, V equal to H by 3 into A1 plus AN plus 4 into even areas plus 2 into remaining odd areas, so that we are getting the answer of 3,30,250 meter cube. So these are all the problems which are related to calculation of areas and volumes under unit 2. Thank you.